So thank you very much for the ICOS Cities people to give me a chance to chat to you today about data, a little bit about basic research data management practices so that we all can manage to keep our data tidy, that is well organized, safe, so that you don't lose it or somebody else comes in and hacks it without your knowledge. And of course, to share the data with others and in the long run also really fostering reuse of data, because we put all of these efforts into collecting and creating data, and then of course we want them to be used both by ourselves, maybe by our colleagues, but also with the whole wide world. So my presentation today is not at all intended to give sort of the answer or the recipe on how to deal with data. I just want to sort of kickstart a discussion both within the ICOS Cities project, but also hopefully at all of you who are here today, that you can bring these questions and discuss them where you are, at your department, in your research group, etc., in your community. So having said that, let's get started. Let's see if I can. Yes, so I thought we should just have an icebreaker in some sense with a couple of quick poll questions about your current data use or data practices. So Claudio, can you kickstart that?
It seems it already has started.
Really? Okay,
So,
I can't see it because I'm sharing my screen. So maybe you can just.
So maybe, yeah, we need already a little bit input of the participants. So are you guys seeing the poll called Start with 3 questions which you can answer? Because I can only end the poll, and we have like 23 answers. So yes, people do respond that they already, yeah, the poll was already up when the people entered.
Ah, okay.
That is probably my fault. I am sorry about that, Maggie.
Oh, don't worry. We just want people to answer. So I can't see it, so because I'm sharing my screen. So maybe you can just summarize the answers for me.
Yes, well, I could stop the poll and then share the results if you like.
Yeah, please do.
Okay, we will do this then. So thank you all for participating, and we will stop it here. And
now I can actually also see the results. Great.
Yes.
Okay, so that's fine. Very nice to see that a clear majority is at least most of the time organizing your data and metadata according to projects, and that's probably a really good start, because just putting all of your files into one huge folder on your computer system called data probably isn't going to be so good. Even if you try to come up with very smart, good file names, it will become very difficult very soon to get an overview. So that's very promising. Then about backups. So I see that at least most of you have at least one backup. Just keep in mind that having just one backup, even if it is off-site, it probably isn't enough. So try to come up with a way to at least have 2 different ones, and they should not both be at the same place. So having it backup on a hard disk in your office, yes, that's fine, but please make sure you have one at the data center somewhere else in case there's a fire or a bad disk. And then the final question now, do you know if others have used your data? That's very interesting. That's a much more split thing. Many people have said no here. or not sure. And I think that points to an important issue that we'll talk about a bit more about later today. But it really isn't very well structured in the way when we write articles or other reports about our research. It's not also always so easy to figure out how to clearly cite data that you have used, your own or others. And of course, so many of these indexers of journal citations in journals are not really picking up on data citations rather than article citations. So that's also a very interesting thing, that only very few people are sure that people have used your data and cited properly. So that's something that we all as a community need to work on. Good, and then let's move on. So I don't know if you can make the poll window go away there, Claudio, so that we can continue. So, as it said or alluded to in the invitation to the webinar, many people are talking about what they call a data tsunami, because it's like data is just growing and growing and growing in amounts and different types, and where you can find data. Much of it is being made available online without any restrictions. Okay, other data you have to ask for still, or etc. But it's really washing over us like a big flood or a big wave of water. And I found when preparing for the talk just a number which is really kind of crazy to me, that in 2021 they estimated that approximately 80 zettabytes of new data were created, adding to the many, in total, many zettabytes created previously. So that's an enormous amount of bytes. Of course, not all of that comes from research or is related to research, but a whole lot of it can be used for research in various ways. And sometimes in quite new and ingenious ways of combining things and seeing correlations that no one had thought about before. So this is really a fantastic opportunity for science, and not the least this COVID crisis has shown that when people are pooling together and sharing data and with others also in other disciplines than their own, you can very quickly make great steps forward towards both asking and answering scientific questions, and that are helping both researchers in basic research, but also society as a whole to understand what is going on. And of course, when the data are there in a digital format, you can apply machine learning and artificial intelligence, etc., to crunch through these very large amounts of data. And that's really necessary because humans cannot just deal with everything themselves. Of course, it's the humans that are writing the basic underlying algorithms and software that are behind the for instance, machine learning and AI, but it's the number crunching is done by machines and often in a quite automated way. That's important to keep in mind. Data as such is of course also expected to be a driver for what is called the global digital economy. So data and data being available is to industry also, without them having to really pay anything for the data if it's produced by publicly funded research projects. Yeah, you can say a lot of things about that, whether that's a good thing or a bad thing, but it's there. And I think it's maybe not as big a thing yet as politicians and stakeholders were hoping that it would be, but there are enormous amounts of resources being spent on providing data infrastructure like storage, access, catalog, etc., both for the benefit of research, but also for industry and the commercial sector. And one example of that is, of course, the European Open Science Cloud that is being built as we speak. Oops. So that's good that there are all this data available for you as a researcher to use. But at the same time, of course, there's an increased pressure on everyone that also your results and your data that you are creating, maybe based on other people's data, maybe things that you are observations that you have made yourself, or modeling and whatever, that all of this should be easy to find. It should be well documented. It should be following standards, so that both human and especially these machine processes I mentioned earlier, that they can really more or less unambiguously understand what the data is, what's inside of the data, and then make use of it. So it should really be simple to reuse. And as much as it's possible, all the data should be free from unnecessary restrictions and conditions. I mean, so this ends up in this statement that it should be as open as possible and as closed as necessary. And that, of course, in much of natural science, and maybe especially this when you go out and study ecosystems or measure fluxes and similar that you guys are doing, then you don't have a whole lot of personal information involved here. So we don't have to worry so much about the data that we are sharing and the contents, because it's not like medical research, for instance, where you would have patient information enclosed in it. And then, of course, you cannot openly share with anyone. But at least you can tell the world that there is data, even if you have closed data. So you can share a lot of the sort of basic metadata about your data anyway. And so really, we have to all respond to this and make sure that we do a good job of sharing also our data with others, so be prepared to do that. And that means that we also have to make sure that we organize the data in the first place. Because if we cannot even be sure of ourselves, say a year after a data set has been produced, exactly how was it done, where is it, what's actually inside, and all of these things, then obviously we cannot share it with anyone else in a successful manner. So the process sort of starts with ourselves. And of course, this sharing your data, that's just part of this new paradigm, as it's often referred to, of open science, which is not at all only about open access to publications, which a lot of people have heard about, or indeed open source software and things like that, but it's also very much about things like open data, having open peer review, really being transparent with everything that you do, so that also other researchers, but maybe very importantly, citizens can at least get an idea about what it is that is happening in this research process, and connecting it to also other things like open educational resources, etc. So it's really making research available to everyone who is interested in getting engaged with it, and being able to, at least in principle, to also try to do their own research on other people's data and etc. So that's also something that we really have to accept, that it's there to stay. So we cannot suddenly turn open science back into sort of semi-closed science as it used to be. And of course, sharing is caring, as some people say, but it's not always so easy to do, even if you are very positive towards sharing, because there's a lot of things you have to think about, and maybe also a lot of things that you have to change, maybe minor tweaks to the way that you are doing science today, because just to make sure that you open up these possibilities to others. So about 10 years ago, a group of people from life sciences in the US, they produced a really funny and maybe also sad video, which is called a data sharing and management snafu in 3 short acts. And it's available on YouTube, and it's only about 4.5 minutes. So I thought I would actually share it with you now. So I will see if I can share the video with you. So please let me know if you have difficulties with the sound level. Should be, I'll crank it up to max here. So while we watch the video, keep just a thought in mind about do you recognize anything that is happening here or being described? Has it happened to you maybe? Or you know of people who have been in similar situations, and we'll just please feel free to put your comments and reactions to the video in the chat.
Hello. My name is Dr. Judy Benign. I'm an oncologist at NYU School of Medicine.
Hello, Dr. Judy Benign.
I read your article on B-cell function. I think that I could use the data for my work on pancreatic cancer.
I am not an oncologist.
I know, but I think I could use the data for my work on pancreatic cancer. Do you have the data?
Everything you need to know is in the article.
No. What I need is the data. Will you share your data?
I am not sure that will be possible.
But your work is in PubMed Central and was funded by NIH.
That is true.
And it was published in Science, which requires that you share your data.
I did publish in Science.
Then I am requesting your data. Can I have a copy of your data?
I am not sure where my data is.
But surely you saved your data.
I did. I saved it on a USB drive.
Where is the USB drive?
It is in a box. It is in a box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need that back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No. I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosynth.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you can buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah yes, SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is, and SAM3. And SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
Okay, so I don't know if this video made you laugh or cry or a bit of both, but that's unfortunately the way that reality looks still very much all over the place, and certainly not just in life sciences and medical research. So I don't see any reactions in the chat, but please feel free to add what you felt about this, if you recognized this or whatever in the chat, or we can talk about that in the Q&A session later on. Okay, sorry, wrong direction. Here we go. So how can we cope with these pressures about opening up our data, making it available for others, and also, of course, preparing data to be analyzed not only by humans, but by really by computer-driven processes? Well, we need to make some reflection and introspection in the way that we are working, and we need to start talking about this in our research groups, in our research context projects, etc. So first of all, take a deep breath, put the kettle on, like the Brits say, and make a cup of tea or coffee, and then sit down and take stock of the situation. So try to find out more about research data management, FAIR, open science. So it's a field full of acronyms, and that's why I on purpose put this sentence like this, because that's of course not helping all the time to be transparent and really understanding what it is that you're doing, but it's so you need to really do your research before and check things out. And then start this dialogue, as I said, talk about are we really documenting our research process in the right way? Are we storing data properly, both during the project and then, of course, archiving it or disseminating it afterwards? Are we sure it's safe? Do we have it under control, or are we just haphazardly mixing things from the data collection part to the raw data with data that is being created during the analysis project, and then finally the outputs of the research? I mean, are there ambiguities and clarities there? Do we always know what is where, and does everyone in the project know about these things? Then, of course, thinking very crucially about this thing, publishing data together with papers. What is it that you should be sharing? How? Should we just putting things in a repository or put things in supplementary materials? All of these things you just as you start sort of planning your paper already at the beginning of a research project or papers, you also need to figure out what to do with the data, not just the analysis and result stuff. You should consider using a data management plan tool, and there are many of those available in the market, and I'll give you a couple of links at the very end. And of course, ask for help if you are confused or don't know what to do. Ask in your institution, at your university, etc., or ask colleagues and have this dialogue and try to figure out what to do before it's too late and before data has been lost. And one helpful way of thinking about your research project, and this goes both for very large projects like the ICOS Cities or ICOS projects and other huge European funded projects, all the way down to that very small master's student work that's being done only locally at the university department or something. It's very helpful to sort of break down the whole process into steps. And this slide is just showing one way of doing that, where you sort of starting from the hypothesis and proposal stage, you move into collecting data or finding data that others have produced that you're going to use. Then you move on to, sorry about that. Move on to processing and analyzing that data. Of course, you will get some results in the end. Sometimes you need to go in a small sub-cycle and collect more data and things like that. But in the end, you have some data results, then you need to curate them. So that is really make sure that they are stored and organized and cataloged and described and all of these things. And then you move on to finding a long-term home for them, for the data that you have decided to save. You may publish it formally and start distributing it to colleagues, etc. And then that invites then reuse by others who will again start the cycle by proposing a hypothesis and a project of moving on, and then everything cycles on. So each of these steps has something to do with data management. Of course, in the beginning, it's all about the raw data and maybe how do you calibrate instruments and things like that, so you really get the data that you can start to process with. And then in the analysis process, it's not just the data, you also need to think about documenting which model did I use, which algorithm did I use to process the data, which software package, and keep also the code that you use safe, so that you can either distribute that together with the data in the end, or at least you keep a very good record of exactly what it is that you were doing, because that's the provenance of the data, to follow the trail of which steps were used during processing. And then it's about engaging with what tools and platforms do I have them for taking care of storing and disseminating the data in the end. What does my journal want me to do, etc. Does my host university or institution want me to do something special? Well, of course, we need to fit into those rules and structures that are provided for us to work within. And finally, also your subfield of science or research may have certain ideas about and traditions about this is the way that we format the data, this is the way that we share our metadata and things like that. So we cannot just rush off and do something just spontaneously because we think it's a good idea to do it. We really need to make sure that we fit into the expected pattern of things, and that will make it much easier to fulfill all of these demands that are put on us. So then there's something called the FAIR principles, which I think that most of you have probably heard about. So this is a set of guiding principles that are trying to encourage comprehensive and sustainable data management and really support and facilitate computer-based data processing. And this is covering the 4 basic categories of actions here to make the data findable, accessible, interoperable, and reusable. So I'm not going to go really into the details here, but you can check out the principles yourself. There are many different places on the web where you can see both the principles themselves and sort of an explanation of what they mean. What is very important just to keep in mind is that just because you manage to make your data products sort of very FAIR compliant, so that they are really findable, accessible, interoperable, and reusable, that doesn't say anything about that the data themselves are of high scientific quality or that they can be used for whatever purpose. And FAIR is also not equal to open. So you can have a completely FAIR data set, but it's not openly accessible. And that could be, for instance, medical data. But you can also have the other way around, that you can have completely open access for some data. Everyone can download it, but it's not following the principles because it's not properly described in the right way, etc. So just looking a little bit more into details here about what does it mean to be FAIR. So I don't know if you can really see this slide so very clearly now when I'm sharing it on the screen, but you can download the presentations later on and check it out there. But so important things are here is, for instance, that you should get the persistent identifier for your data. So this is just like you get the DOI for your article that you're publishing in a journal. Also, your data can get these persistent identifiers. And that means not only that it has an identity, but also that people only need to know this identity number to be able to access at any time afterwards both the description of what the data is, that is the metadata, and also access in most cases the actual data item itself. People don't need to keep a path in mind or anything else. They don't need to know that it's stored at the ICOS Carbon Portal or whatever. You just need this ID number, and then you can, as it's called, resolve it by typing it in the web. And you get redirected to the place where the information is. So that's really valuable, because as we know, web links and things like that you share with people, they tend to be broken, etc. But the identifiers are supposed to guard against that. So both provide a unique identity so that you don't mix things up, and also allow for retrieval of the object or its information at any point. Another very important point is that I don't know why my pointer isn't working, is that the metadata is what is called rich, so that you really try to couple all the descriptions that are necessary for reuse of the data to the data itself, so that there is information about the contents, about who produced it and where and what, and all of these basic things. And the more you put in and the more you associate with the data, the better. Because as I said before, really, how many of us remember all the details about the data set that we produced a year ago, or maybe even a week ago? If it's not documented and easy to access, then it's sort of lost. So that's an important point. And one more point that I would like to make today is that it's also very important to think about attaching a license, a usage license to your data, so that it's clear to anyone who may be interested to use it. Am I allowed to do this? And are there any conditions attached to this? Or is it enough that I just really refer and give a proper citation of the data when I use it? So the typical CC BY license that I think many of you are familiar with, that just simply means that yes, you can use this data for anything you want, but you need to acknowledge where it came from. So out of all of these principles, all of them are important, but and have different bearings on what happens. Not all of them are in your control as a data producer, but a lot of it has to do with the way that data are managed in repositories or other organizations. But it's important to be aware of all of these things so that you can make good decisions. And then now, very quickly, I just want to go through a couple of slides with some more concrete suggestions of things that you can do and why it's important to you. So trying to make your data fair, or at least as fair as it is reasonable to make it with the resources and time that you have, that is very helpful, because it will help make your data sustainable both for you and your co-workers and for the rest of the world, so to speak. It ensures that your data can be found so that people know that there is some data there, and then ultimately, hopefully, it can be reused. It facilitates your process of thinking about how to collect metadata, which metadata to collect, and how to connect it with your data and everything else in your research project. It will guarantee that your data can be cited properly, and if it's cited, then ultimately you can also get credit because you can show that other people have used it. And it will facilitate all of this extraction of usage statistics and other things that your funders want to know. I mean, is that all this money that we're pouring into your project, was that good or it was for nothing? And it also helps you streamline your cost estimates for paying for data storage and data curation and all of these things. And finally, it really makes data management plans easier to write. And nowadays, almost all projects require you to, all funders require you to file a data management plan for your project. So keeping all of these things in your mind, and as I said before, talking to your colleagues really helps doing that. It might take a lot of time to make your first data management plan, but once you've got going on it, it will be much simpler. So here, just a few very concrete steps, and I won't give any details here, so I encourage you to go through the slides afterwards and think about, is this applicable to us? How can we do this? But you can see here this sort of a summary of many of the points I made before. You need to make a plan. You need to think about how to store your information, have logical folder structures, and of course also file names that are descriptive. Make sure you collect and document descriptive information about the processes, about the data, etc. throughout, at least for your own sake, and keep this in a way that your whole project can share and read and refer to. Use standards and data formats that are common to your discipline. So if everyone else is using NetCDF files, then probably you should also use NetCDF files for distributing your data. Keep at least 2 separate backups of everything, both data, metadata, and also very importantly, code. And of course, version things. So don't overwrite your code. So you lose the earlier version of it. Always keep these versions separate and keep good track of what is what. And connect with your data and your metadata, what was used when. And then at least at the end of the project, make sure you store your data in a trusted and sustainable repository or data center. And be aware that most data centers, unless you really specify this, may only be thinking about the 5-year horizon. So if you want to keep your data stored for a longer period than that, you need to take special action. As we said before, make sure that data gets persistent identifiers, but it's not just the data that should be getting a PID, as it's called. Also make sure that all the persons involved in your project get an ORCID identifier or similar, so that they can be unambiguously identified, and then connect that to of course, the data on who was doing what. Apply a suitable license. Also provide end users with some information on what the intended use of the data is from your perspective. That will at least help to avoid some misuse or wrong use, or however you might call it, of your data by others later on. Make the data as open as possible, but as closed as necessary. So be sure that you check up with your GDPR officer that there isn't any problem with what you're putting into the data sets, and you may need agreements from everyone who is involved that it's okay to share their names, etc. Also, make absolutely sure that even if the data or data sets for some reason are deleted or lost or whatever, that the metadata about them is still there if possible, and explain why the data has disappeared if it has, just as a service to people coming later on. And try to, once you've done all of these things, try to test the fairness of your data to judge how far along you are, and get some hints on what you might still need to improve. And then finally, just a slide with some useful links in no particular order that you might find useful to figure out different aspects of what I've been talking about today. So to wrap up, let's just close with this a couple of more poll questions. And while you are responding to the poll, etc., please don't hesitate to put more questions in the chat. I see one question there now. Thank you very much. We'll deal with that in a second. And put more questions, and also any other comments that you would like to make about the presentation today. Thank you. So let's see here about what you think about these wrap-up questions. Okay, so I think we can close the poll now. 2/3 of people have answered. So I'm very glad to see that all of you almost agree that spending just a little bit of time every month to sort of check up on the data management that practices of your project, that you're following the plan and thinking about these issues is not too much. Actually, I think that's really a lower limit to where you can go, but good to see that you are happy to keep this in mind actively. Then regarding who should actually be doing this management of research data, no one suggests that we should leave this completely to information professionals, and I think that's very wise. But I think we cannot manage to do all of these things on our own and make all these decisions, because we aren't really trained with all of these detailed aspects, and also the landscape of data management is changing quite rapidly in terms of which tools are becoming available and best practices and etc. So it's good to have a collaboration with, say, your research library or something like that. And finally, are you feeling inspired to start a data discussion? And except for one person who is a clear minority here, all of those, most of you who answered just said yes. So I'm really happy about that. So I think that that was it for me. I spoke too long as usual, but there's still at least 10 minutes for questions. So also, if you don't have a question today, you're always welcome to get in touch with me afterwards at any point if you want to discuss data management.
Thank you, Maggie. This was a very, very interesting presentation. Thank you for it. So we do have one question in the chat. So I think we'll start with that. So Yvonne is asking, in order to attach rich metadata to your data, how do you practically do that? In a separate file, or does it work? How does it work at best?
Yeah, so that's a very good question. So I think that often you need a combination of the different approaches here. Of course, if you have metadata, some metadata, for instance, about the process or the protocol that you make for a type of measurement, that is probably best kept in that kind of report format or as a document. And then you want to link that document to your data by, and often it depends a bit on how your metadata is stored, but often you have access to a kind of what is called a schema, which is really a set of different fields that you can fill out. And there could, for instance, be one field called associated objects or something like that. And then you could add a DOI at best to pointing to this protocol report or other reports so that people can easily find it. Then there are more concrete things like maybe a list of variables that are contained inside of a data set. That is probably best put inside of a database where the metadata are as digital separate entities, so that again both a person but also a machine program could go out and check them out, follow them, get a list of these definitions, and maybe also be able to then verify that, okay, so here's a field that it says it's a NEE. Okay, so is this a field really, does it really contain any E values, for instance, net ecosystem exchange values, or is it mislabeled, or is the unit crazy, or things like that? Or so that you need to put things in a way that it's very clear, and also, if at all possible, directly accessible and searchable in the metadata. I don't know if that helps answering your question, Yvonne, if you
yes,
feel
very
that
much.
yeah,
Thank
good.
you.
Yeah, so I mean, you really need to look at each concrete case and analyze it and find the best way, and also to compare of how do other people do this, and follow community practice if it's possible.
Thank you.
Okay, thank you. Then we have Thomas, who has raised his hand. Go ahead.
Hi, Maggie. Thanks really for the talk. Very important indeed. Well, just a very practical question. Do you have any recommendation, like for any template or some checklist? Because I assume like you thought about it a lot, and rather than coming up with my own, of course, recognizing that each field and each situation is different, but maybe it would help to have a start from something. Thank you very much.
Yeah, that's a very good question. I don't have sort of in my direct mind a really good comprehensive checklist that would fit, as you say, every field, because it's often a bit community specific or domain specific, exactly what to do. I think you could start using those basic points that I had in my slides, and you could maybe build up your own checklist from that.
Maybe one thing I'll elaborate, if I may, is like, do you like use like maybe one master document from which you then have like everything else organized, or like, because when I was trying to do this before when collecting data, like I always got kind of lost, and like ideally for me, I would have like a wiki kind of thing where I would just, have like the main structure and then like go into details or something like that. This is basically what I would have in my mind, and I'm just wondering whether I need to develop it or something like that. Thank you very much. Sorry for the two questions.
No, those are very good questions and very good points. I think it's good to have one place where you, for your project, so to speak, or your collaboration, where you outline these basic things. And you can think of the data management plan as such a document. There are many templates available at very different levels of detail, or asking for very different levels of detail. So I think one can start maybe the first time you do it with one of those sort of more overview and more generalized things, and then you move on to one of those templates which is really asking detailed questions. How does your folder structure look? Have you which data center will you store the data at when you're done, and all of these things. And then you get things that you can document and tick off. I've done this, and also of course revise after a while, because you should always revise your data management plan at least once per year to make sure that it's still up to date. Things may have changed. Maybe you decided not to use Amazon Cloud, but you're going to store data at your local data center instead, and then you need to document that, because ultimately, also your funder might suddenly turn up at your door and ask, we want to make sure that your data management plan is up to date. And then you have it there. You just say, yes, sir, here it is. And everything is clear. And then you will also see where there may be problems appearing that you need to act on. Hope that helps.
Okay, thank you. Then we have from Daniel, and he says, thank you for the talk. And then he asks, are there any tools you could recommend for data management?
Well, I'm not sure what you mean with tools there for data management, because it's a very broad thing. I think you need a lot of different separate tools, so to speak, and which ones you are using, I think, or should use, depends very much on your context. It can be that your, for instance, university or employer, that you already have some policies about this, and then you should be trying to find out what those are and then follow them. And policies can sometimes be only very general advice, but they could also contain very specific pointers to you should be using this data center, or you cannot use these and these and these resources because they are not compliant with whatever. But in general, yes, please go ahead.
Maybe to clarify a little bit, I know GitHub, GitLab, those are pretty nice programs to version your code and to, yeah, basically the tools I use for code. But are there is there anything similar that can be used for data management? So basically that was my intention.
So which aspects of data management do you mean now?
Yeah, that's a good question.
No, it's just a little bit vague, so it's difficult to answer.
Okay, yeah, basically to version data, if I manipulate data, okay, I have a raw data file, I have pre-processed, I have my final processed file, something like this.
Yeah, well, first of all, one needs to recognize that you need to keep all of those different versions of the data separate. And there may be very different tools needed for each of those. Often, maybe, especially if you're doing like covariance studies and things, you know that your raw data are huge. But you often analyze this into then half-hourly fluxes or whatever, and then suddenly you only have a few megabytes left, etc. So you need different strategies for dealing with these things. Of course, the really raw data, you should never change. You should, if you want to apply calibrations on it or whatever to make it sort of a file maybe with physical parameters rather than just voltages or something like that, you make a new separate version of it. And this is now not raw data, but it's calibrated raw data. And then you have your analysis things, like you said, intermediate results and etc. You need to keep all of those separate. And of course, for each of those things, when you are sort of happy with it, you can get a persistent identifier for it, for instance, and you can make an entry in a catalog that you have where you collect the basic metadata about this. If you make any change to this object, then it becomes a new object. So you should not reuse the same PID for it as you had for the original set. You get a new version, and then you clearly say in the metadata that of the first file, this has been replaced by this new thing. And in the new data, you say in the metadata, this is replacing the original, etc. So then you keep the relationship between objects so that you can follow chains of change. And then you communicate that clearly, of course, in the next step. If you're redoing the analysis because you had to change something in the input data, then your output of that process is again replacing the first attempt, etc. And I don't think there are any versioning tools as such that will help you to identify which changes were made inside of the data, like you have for GitHub when you're identifying changes in code. You could use, of course, if it's text-based or whatever, you can identify changes, but I don't think that's very useful. I think it's better than to write a short release note that this is what changed because we had to do this and this and that. And then it's always also a question of, should you keep data sets that you know are faulty? I think if it was ever referenced in any publication or in any report or whatever, you should keep also bad copy, so to speak, at least for some period of time, to allow people to go back and verify the scientific process. But of course, you can choose to not only deprecate an object, but actually get rid of it if it's huge and it's taking up a lot of space and you're paying for it or whatever. But then again, describe that in the metadata of that original object. Keep the metadata and explain that there was an obvious error and it was completely useless, and that's why we have deleted this now.
Thanks a lot. Yeah.
Okay, thank you. Then we have actually a bunch of questions from Marcel, and he asks, how do you manage your code? Do you use GitHub, GitLab, SVN, etc.? Do you also use linting for your code to clean up? This is not a familiar word for me, linting, but I'm hoping I got it right.
Yeah, I actually do not write code myself, so I don't use any of those tools, but I certainly would be using Git, that whole Git system for keeping track of my code. And that's also what we are doing, for instance, in ICOS. I don't know if there's someone from ICOS Carbon Portal who would like to chime in and add some more information about this, but in general, that's what I would recommend, I think. And also to make sure that you have a clear license for your software and code if you're going to share it. So if you're going to use a GNU license or whatever, then be really explicit and clear about that so that people know what to expect and what to do.
Okay, thank you. Then we have a question from Matthew, and he's asking, how do we improve or influence a culture of better data management by colleagues who do not will not engage?
I think you just keep doing the right thing yourself. And of course, this can be difficult to change the culture in an organization. Here at Lund, together with Harry Lankrayer from ICOS and other colleagues, we have had a course for PhD students about the introductory data management, covering pretty much all these things that I talked about today, but also, of course, in more detail. And one student came to me afterwards and said that they were really, really happy about the course, but they had discussed these things with their supervisor and had just met the complete dead end, because that person was not interested in changing the folder structure and organizing data in a better way. And all I could say was that that was really a pity, and that I hope that the student would be able to in their new job, once they are graduated, to be able to have more influence on the way things were being done. And of course, keeping their own stuff tidy and well organized. And I think that's all we can do. Maybe just use this argument, which is maybe a little bit harsh, but still very true. And that is that when we do science, we sort of implicitly sign up to a contract of doing things in the right way, right, in an ethical and professional manner, and having a really sketchy way of dealing with your data and metadata and all other resources related to your research that is not organized and not easy to reproduce, etc. That is really breaking that sort of social contract as a researcher. And it opens you up to being vulnerable for being accused of not doing science in the proper way. And even if this is a sort of false premise that there has been some kind of fraudulent activity, if you're not organized and if your stuff in the end cannot be reproduced, then you are in trouble. So keeping your own stuff tidy and safe and reusable by yourself and others is really, in my mind, a bare minimum of process that you need to do as a researcher.